Undeniable flat earth proof. Yep, that's the claim again. I was looking through Kyle's from the Flat Earth Institute of Science. I was looking at his list of top flat earthers and I thought there's got to be something good here. And I've found something good. DMarbles. I haven't looked at him for a long time. Marbles has a video, Undeniable Flat Earth Proof. The 10-mile Puget Sound laser test. Well, Mr. DMarbles, roll VT. Well, I can't disagree so far. Flat Earth is quite offensive.
Alright, so now to get started, let's look at our positions on the water. Now, Mark was at Owen Beach at Point Defiance Park. And you'll see his laser fade in on the horizon. And I was positioned at Saltwater State Park in Des Moines, Washington. Now, while we're here, let's take into account what these two land masses would look like from my position facing towards Mark's position southwest.
Got that? That's all nice and clear. Promontories 1 and 2. Thank you.
Alright, so the distance between these 2 points is 10.3 miles. Mark's going to say in a little bit that he's about 7 feet above sea level. That gives us a target hidden height of 33.2 feet.
Again, all very clear. 10.3 miles apart, a laser height of 7 feet, which gives 33.2 foot of curvature. Nice.
That what? I'm going back on again. Yeah, bring it back on. Yep.
Is that a lightsaber?
Let me see. You're about dead on. Just a second.
Boom, boom, boom. Alright, bring it to the right. Bring it to the right. Little bit. Alright, stop right there. Bring it back a little bit.
And Dozy, do your partner.
Ah, shoot. Hold on. Wait. Stay right there. Stay right there. Here, let me hit record.
That sounds like a good idea. Recording a laser test without actually recording it is probably not a good idea.
Ah, shoot. We're out of focus. Still see it, though. Look, we're out of focus and we still got a picture on the laser. Now, I zoomed in, it kind of looked like one of those stars.
That will be one of those star pictures taken by flat earthers where they use a P9000, can't focus, but still get all moist and unnecessary over.
Alright, hold on. Let me try to get this thing focused again. But yeah. I see you, man. Here, point it back to the left a little bit.
Your left?
Yeah. Yep. Bring it back just a hair. Boom, right there. That's perfect. Stay right there.
Well, right now, things are looking good. You've got that laser shining across the lake and you're picking up nice and clearly on your camera.
Stay right there. Honestly, what's your elevation right now? You're in the water right now?
I'm checking the heights right now.
Awesome. Alright,
let's see. I would say 7 feet off the water.
About 7 feet off the water? Okay.
7 feet off the water. Okay. Got that?
At this point, I'm anticipating that someone suffering from cognitive dissonance is going to say, no, he was more than 7 feet above sea level.
No, he was...
Okay, so let's say 8.5. Now, where's the other 30 feet of curvature? And then somebody else is going to say, no, he's higher than 8.5 feet. Okay, let's try 10. So where's the other 27 feet of curvature?
Have you looked down the back of the sofa?
Yeah, stop it.
Hold on, let me back this thing up a little bit. The water's coming in. Yeah. Give me a few seconds. Back it up just a little. Then I'm going to adjust my tripod.
A brief intermission while DMarbles adjusts himself. As always, massive thanks and appreciation to all my patrons, including new patrons Elizabeth Sagan, Michael Burnham, Brian Ramsey, Sharpworks, ex-Penguin95, Stephen York, Uwe Closer and Wee Scott's Dog, and my latest patron, Marconius. Thank you all so very much.
I'm lower this time, so I got the camera like at about 3 feet above the water, somewhat. You know, got the tripod down low, so let's see what you got now, man. Let's see if I can find you.
All right, hope there's enough power in this. It takes quite a bit. Here it goes.
Okay. All right, hold on. Oh, yeah. Hold up. Wait. Stay right there. Right there. Let me get you. All right. So, okay, so hold on, dude. You see it right here. All right, folks. Boom. There's a laser right there.
Yep, there's a laser light right there.
All right. My tripod is nice and low. You see me? Boom. We're 10 miles away. I can see that laser. Mark, about how high are you above the water?
Right at about 7 feet.
He told you that 2 minutes ago. 7 feet.
Right at about 7 feet. And you're like kind of pointing downward toward my position there, and that's cool.
Hold on a minute. He's at 7 feet. You think you're at 3 feet. He's 10 miles away. And you're saying he's pointing the laser downwards. How can we tell? Have we got some sort of measure on that laser? Or just your Mark 1 eyeball?
Dude, I can see the laser with my naked eye right now. Everybody can see it off in the distance. I'm not even looking into the camera right now. We can all see the laser together right now. 10 miles away, dude. Here, let's get lower. I'm going to put the phone down here. I'm going to put the phone down here on the ground. And we can still see the laser. Yeah? Huh? Everybody still see it? We're on the ground right now. 10 miles away. Huh? Do we need to get into the water? Let's get into the water a little bit.
Oh, Marbles, no skinny dipping, please.
Huh? Oh, look, people. Hold on. We're in the flipping water, and you can still see the laser. Checkmate. That's game. That's game. That's game. Is it not? That's game, dude.
Well, we'll see about that.
Consider what you see in reality and ask yourself what makes the most sense. Water doesn't mysteriously start to curve downward after 10 miles.
Well, first of all, I'd like to say thank you, DMarbles, for doing this experiment. And I'd like to try and break down a few things because I've got a couple questions. First of all, let's start with your camera. You show us that it's on a very low tripod. You also show us that you're very close to the surface of the water. I've got no real quibbles with that. The only thing I would suggest is if you actually measured the exact height of the camera. Other than that, good. The other thing I thought I'd do is look at the location, which is Owen Beach, Port Defiance. And there we go. Let's zoom in a bit. And we can quite clearly see there's Owen Beach. You're over here somewhere. And these are those two land promontories that you found. Okay, fair enough. You see, I've got some definite concerns about the height of that laser. Let's have a look at it again when the height was discussed. Now remember, this laser is supposed to be at about 7 feet.
You're in the water right now?
So that laser is at 7 feet. That guy is down by the water. Does it really look as though that laser is, let's say, 1 foot higher than a 6 foot man? It looks to me as though he's got quite a walk up that beach to get to the laser. I don't believe that that's 7 feet.
7 feet off the water.
About 7 feet off the water? Okay.
So I thought I'd have a bit of a poke around and see what there is at Owen's Beach. So let's have a look at Owen Beach then. We just zoom in a bit. Very nice looking water. And if we come past and turn around, ooh, there doesn't seem to be a lot there. No, just beach, bit of grass, car park. I think I'm going to have to investigate elsewhere. I decided to have a much closer look at the video to see if I could spot anything else at all. The only bit of video with movement at the laser end is this clip, and I'll loop it. You can see the water being quite a distance down, although it's hard to tell. But there's something else, and I'll pause it right at that point. There. You can see the laser on a little tripod and the guy's torch resting on a wall. So we do have something identifiable. I need to do a little more research. I looked again at the Google Earth image. The only man-made construction that appears to be visible is down here, near the car park. It's hard to tell what it is, but you can see there's a little wall here. As Jerrinson would say, interesting. Well, a quick Google and I came up with a couple of pictures from Owens Beach. Here's one showing a grassy area to the left and the beach down the centre and the little wall. And then I found a second picture, much similar. Again, it's very hard to tell how high that little wall is above the water level, but you can see that the beach slopes down quite a bit. Let's look at one last thing, the laser light itself. So here's a screen captured image of the laser. Now to my eye, it looks as though that's curving down slightly towards the end, but I admit it's very, very hard to see. So let's reduce the exposure and brightness and see if that helps at all. So if I increase the black level, maybe a little more, and reduce the exposure, I think that'll do. Let's have a closer look again. Yeah, very, very difficult to see. Now we'll try and drop a line along it. I'll try and be as fair as I can. So perhaps from there. Ooh, zoom in. Say to about there. It does look to me as though it's curving down, but almost impossible to tell. Now you used the Earth Curve calculator from GitHub. You started off with a distance of 10.3 miles, height of 7, then 8.5 and finally 10 feet, pointing out that the target hidden height would be 27.5 feet. But why didn't you use Metabunk's calculator? Let's put in the viewing distance, 10.3 miles, view a height that you eventually ended up with in feet of 10, and that gives us, as you saw, 27.5 feet. Geometric hidden. When you start taking refraction into account, that drops to just over 21 feet. It's about 6 or 7 feet less. Now I know you're going to still say, well, that's still not enough, it should still be hidden. But this is a refraction approximation. Refraction varies with temperature. Also note, it says, not accurate for observations over water very close to the horizon, unless the temperature and vertical temperature gradient are accurate. So overall, I think it was a nice try. I'm not going to say that there was anything underhand here, but I think you need to do it again. Let's have an exact height measurement on your camera above the water. Let's have an exact measurement of the laser height above the water. Perhaps a photograph showing where it's situated. Then you must take into account refraction, and you haven't. Light gets bent by changes in temperature and density of the air, and that happens all the more so close to water.
Spread the truth, expose the lies, and demand answers. This is the Flat Earth Offensive, and you are the resistance.
Anyway, I look forward to another attempt, DMarbles. Until next time, guys, stay sensible.
Shut up and sit down.